Namaste, Sathi students. I'm Priyanka Raji from Department of Mechanical Engineering, IIT Kanpur. So this is lecture 7 of laws of motion, and today we will be continuing our discussions on tension, and we will be starting some problems on pulley and block. Okay, so we were discussing on string with mass. So how to solve the problems on string with mass questions, and we were seeing how to calculate the tension at various points on a string with mass. So suppose this is another question where you need to find the tension acting at this point. So this tension acting at this point, which is like x unit which is at x unit distance from the end of the string. Okay, so this string is hanging from a surface, kind of like a ceiling. So it is hanging, and you need to find the tension, which is like x unit length above the end of the string. Okay, the total length of the string is L unit. So how to find this? You can, so what you can do is, so this is, let's take this mass of the string as M. Okay, so M unit mass is there. And we were talking about M, how to find the mass of the various session, right? So M mass for L length. Okay, so what will be for 1 unit length? 1 unit length. Okay, you can take it the other way. So this is like, okay, if you take it like this, you will understand it better, right? L length has M mass. So 1 unit length has what? M by L mass. So X unit length has what? X times M by L mass. Okay. So this is how you find the mass of this session. So this can be drawn like this also. Okay, like there is a ceiling from where the string is hanging, and this is like now L minus X length. The total length of the string was L, right? Now you will take this as L minus X length, and this part you can take it as a block with mass X M by L. Okay, you can take this as a block. You can consider this as a block. Okay, kg. Now this looks something like a simpler question, right? You can understand what will be the reaction force here. So tension is the kind of like a reaction force. This is the mass of like the weight of the object, and this is kind of like a tension force. Okay, now we will see how to find the tension here. So what we will do here, you know that this thing is not moving vertically or horizontally. So the acceleration of the system is equal to 0. A equal to 0. Okay. Now for finding tension, we will take the free body diagram of this block we were talking. So free body diagram we will take. So this will have X M by L mass. So weight will be W equal to X M by L G, and reaction is N. So not N here, it is T here because it is on a rope. So we were saying that there is a tension force that is acting to along the string. So that we will be taking it as T. There is no horizontal forces along for this block. So net force equal to what? Mass times acceleration. Acceleration is 0. So net force equal to 0. That means T equal to xm by L times G. This is how you find the tension force for a length of x on a mass string with mass. So in the previous problem, how was it? Like, okay, it was not hanging vertically downwards, so weight was not acting. But suppose you want to find the tension at the midpoint of the string. What will you do? You will substitute x with L by 2. So for midpoint, x equal to L by 2. So that means T equal to L by 2 times M by L times G. That means M by 2 G. It makes sense because this is the mass of the string is uniformly distributed. That every point has a same kind of, like every particle on the string has same mass. Like for example, if you cut a small piece of rope here, or with the same width, if you cut a small piece of rope here, both will have m mass, like the same amount of mass. So that's why this is very intuitive. Suppose you want to find the tension of the string at a distance of L by 4. What will you do? You will take this whole thing as 3L by 4, right? Because this point you want to find. Okay. So this is L by 4 means this is 3L by 4. So how much weight this particle is carrying? That will be equal to 3L by 4 times M by L. That is 3 by 4 M. So tension will be what? T equal to 3 by 4 M times G. I hope it makes sense. Okay. So at a distance of L by 4, if you want to find the tension L by 4 from the ceiling, if you want to find the tension of the rope, you will be taking this part. Okay, this part you have to take. So it will be 3 by 4 M times B. So that is how you find the mass of the string. Here, the string itself has a mass. That means it experiences the gravitational force. The weight of the string is significant here. So that's why the string. That's why if you put a if you hang a rope from a ceiling, it will always fall straight. Why? There is a force acting along that rope. That is called tension. Tension basically stretches the rope, right? Now here it's the other way around. You have two masses connected using a vertical rope of mass 1 kg, and it is being pulled vertically with a force of 120 Newton. You want to find the acceleration of system and tension at the midpoint. Okay, so this is midpoint of the string. So this is L by 2. Okay, this total length is L, and you want to find the tension at this point. Or I'll take the direction the other way. So this point I want to find. Okay. Now, suppose this string was massless. What will happen? The whole setup, the whole string will have the same T, right? So this, suppose I'm talking about the condition where mass is not given. The string is massless. Okay, then this will be T. and this will be T, and this whole system will be like this. This is 3 kg, and there is a string attached, and here there is a 2 kg, and there is this weight of the object acting, that is 3 plus 2 times 10, so that is 50 Newton, and here it is 120 Newton. So for finding acceleration, what will you do? 3 plus 2 equal to 5. Okay, and 50 Newton here, and 120 Newton here. And if you take acceleration to be in the upward direction, 120 minus 50 equals to 5 times A. 5 is the mass of the block, the whole system. So that is 70 equal to 5 times A. A is equal to 1 and 4. Right. So 14 meter per second square. Yep. So this is how you find the mass, the acceleration of the system, right? And then to find the tension, what will you do? You will take this 2 kg block. So in 2 kg block, this is 50 Newton. This is T, and it is going with a acceleration of 14 meter per second square. So T minus 50 equal to 2 times 14. So T equal to 50 plus 28 equal to 78 Newton. Correct. A similar manner, if you see the 3 kg block, you can see that 120 Newton is given. Then here here T is given, and it is going with the acceleration of 14 meter per second square. Now to find T, what will you do? What will you do? So this is 120 minus T equal to 3 times 14. So 120 plus 3 times 14 is 42 equal to T. Sorry, wait. I think I made some mistake. So 120 minus 50 is equal to 5 times A. A equal to 14 meter per second square. So A is correct. Now for the downward block, what is the thing? So T equal to T equal to T minus 50 equal to 28. That is 78. That's correct. So here, what happened? Here it is 120 minus T is equal to 3 times 14. Okay. The mistake here is 120 and 3 times 14 are in the same direction. So I should have taken it in the other way. Okay. So 120 plus, that's what I did, right? Okay, I'm not sure what happened here. The direction is the problem. So T equal to 120 minus 42 is equal to 78 Newton. Okay. So you have to take T and 122 as opposite directions, and 42 is opposite to 120. Okay. Or it was other way around. Let me see once again. So this is 2 kg block. Okay, for 2 kg, I did the mistake, I guess. So this is 50 Newton, and this is T. and 14 meter per second square was going upwards. So t minus 50 equal to, okay, plus m times a, that is 28 equal to 0. Okay, so what I did for the 3 kg block was right. So this will be like t equal to 120 minus 14 times 3 kg. Okay. Okay, and the assumption of this direction of acceleration is wrong. So that's why I am making mistake. Why? Because this 50 Newton, when you can see that, okay, here I shouldn't have taken 50 Newton. This is 20 Newton. Okay, that is, first of all, that is one mistake I did. So this is 20 Newton. Second is, so here tension is what? Tension equal to T minus 20 equal to 2 times 28. So T equal to 48 here. Okay, now we will talk about string with mass. So acceleration of this the whole system we have to find first. So how to find that? You have to, okay. So for the whole system, the mass of the object is 3 plus 1 kg of the rope and 2 kg of the block, which is equal to 6 kg. So 6 kg, 60 Newton downwards and 120 Newton upwards. So net force equal to 120 minus 60 times 6 times A. A is equal to 60 by 6 is equal to 10 meter per second square. So acceleration is 10 meter per second square. Now to find the tension force at the midpoint. So this is L by 2. If I take this whole thing as L, that is L by 2. Now we will break this rope at this point. Okay. Now what we will do, this is like 3 kg and a mass of, so how to find the mass here? So this is 1 kg rope is there. So L by 2 is there. So L length has 1 kg. So one unit has what? 1 unit length has 1 by L kg, and L by 2 unit has half kg, right? So this is 1 by 2 kg, and here another piece will be there, another section of rope will be there, that is half kg, and this will be 2 kg here. Okay, now to find the tension force here, you will take the free body diagrams. So how to draw the free body diagram? You will take the whole thing as one system. This is one system, and this is another system. Okay, so this is one system, and the other one, you will be taking this as this section. If I take it as A and this is B, free body diagram of A we are drawing. So this whole thing is 2 plus half kg, 2.5 kg, and mass is 2.5 times 10, that is 25 Newton. I mean, the weight is 25 Newton. And there is a tension force, which is like dragging this object with an acceleration of A. So T minus 25 is equal to 2.5 times A. So T minus 25 is 2.5 times A. That means T equal to 50 Newton. Right. So you have found the tension force at the midpoint. If you want to check, you can use the free body diagram of B. It is like 3.5 here, 120 Newton here. Then this will be 35 Newton and acceleration A is there. So how to draw that? You will be equating this forces 120 minus 35 equal to 35 Newton. So sorry, so you have taken this as 35. It's actually T. You will be getting T force here. 50. 120. And the mass of the block is also there, right? Yeah, that is 35 again. So 120 minus T minus 35 equal to 35 Newton. So T equal to 120 minus 70 is equal to 50 Newton. Okay. Okay, now now I got the mistake in the previous problem. Anyway, moving on. Now the similar problem in the horizontal surface. Again, to find the tension at this point. Okay, this point we want to find the tension. So this is X length. So net force, you know that, is equal to mass times acceleration. So force is equal to F, mass equal to M plus M. The block has M and this rope has M, and acceleration is equal to A. So A equal to F by M plus M. Okay, so that we got acceleration. Now you want to find the tension force. So what will you do? First, you have to find the mass of this X unit. So how to find the mass of X unit length? You know that L unit has M mass. So 1 unit has M by L mass. So X unit has X times M by L kg mass. Okay. So that we have got. Now we will be breaking this rope at this point with the desired point. So how we will draw the free body diagram, it will be like this. So this is one section and this is the other section. This has X times M by L mass and this has X, sorry. The rest of the length will be L minus X, right? So L minus X times M by L. Okay. Now we will be drawing the free body diagram. This X times M by L part, if you take X times M by L is being pulled by F and there is a tension force T and it is going with an acceleration A. So what we will do, we will equate the forces. Net force equal to mass times acceleration. So T equal to F minus Xm by L times A equal to F by M plus M. So you will subtract, sorry. Now you can just multiply and divide by M plus M. Sorry, you don't need F here. Now you will be getting this MF and MF you can take. MF times 1 minus X plus MF Okay. Now there is an L here. L times. Wait. I'll expand this again. So how will it come? So this will be having an L here and an L here. So LMF minus XMF plus LMF divided by LM plus M. Okay. So that means L minus X times MF plus LMF divided by L times M plus N. Okay, so that is the tension force here. So M by L times L minus X F. Okay. Now, if you want to do the same with the other block, we will see once again. So acceleration was what? Acceleration equal to F by M plus M. You have found it. And this tension force here, we have derived it as L minus X times M F plus L M F divided by L times M plus M. So if you take the this session, if you draw the free body diagram, it will be like the whole mass will be M plus L minus X times M by L, which is being pulled by a tension T. Okay, so what will be the equation? Net force equal to mass times acceleration. Force equal to T, mass equal to M plus L minus X times M by L times 4. Acceleration is F by M plus M. Now, if you cross multiply, you will be getting MLF, this M, this M, this L, and this F. With this L will come here, so that the denominator will become ML, or else I'll write it once again. You can take it like ML plus L minus X times M by L times F by M plus N. Okay. Now, if you multiply along with so this is one. Okay, this is one term and this is another term. So MLF plus L minus X times MF. Okay. Divided by L M plus M. This is the exact same thing we have got here. So this and this are the same. So that is how you find the tension force here. Now, another question. Here, two forces are acting. Here, only one force was there. Here, it is being pushed and pulled with two different forces. Now, you want to find the tension at the end of the string. End of the string means this point. Okay. Here, you need to find the tension. Now, mass of the string is given. So that is string with a mass. Now, to find acceleration, what will you do? You will consider the whole system as one. So M2 plus M is being pushed and pulled by 3F and F. So since 3F is larger than F, acceleration will be in this direction. So net force equal to 3F minus F equal to m2 plus m times a. So a equal to 2f time by m2 plus m. So you got the acceleration here. Now, to find tension, what will you do? You will cut at this point. Whichever desired point is there, you will cut there. So that is like you take the string apart and the block apart. So here you will draw the system like this, M2, which is being pulled by T, and another opposing force is there at 3F. And there is the string with mass M, which is being pulled by F, and there is a tension force. So if you consider this block M2, you can write from M2, net force is 3F minus T is equal to M2 times A. So T equal to 3F minus M2 times A is 2F by M2 plus M. Okay, so that is the tension force here. Now you can simplify like M2 plus M, you can multiply and divide. Now you give 3F here minus M2. So this whole thing is M2 plus M times 2F. So M2, 3F M2 and 2F M2 cancels, and you will get F M2 plus M times 3F. So 3FM by M2 plus M you will be getting. Okay, so that is the tension force. Now, if you want to find it from this length of the string, you can use this free body diagram, M, F, and T. So it is going with an acceleration A towards this direction. That is the direction of acceleration for the whole system. So I'm taking the same acceleration here. So what will happen? T minus F, because acceleration is along T. So T minus F equal to M times A. A is what? A is 2F divided by M2 plus M. This is M times 2F divided by M2 plus M. Okay. So T equal to 2FM by M2 plus M plus F. Now multiply and add by M2 plus M. Multiply and divide by M2 plus M. When you expand, you will get FM2 plus 3FM by M2 plus M. So that is the tension force. So in both the manner, you will be getting the same tension force. Okay. Now, we need to discuss about pulley block problems. So pulley is a device which is like used from a very ancient time to lift heavy things, heavy objects. Like due to this cylindrical structure, cylindrical or the kind of like a disc structure, this will roll easily, and you can lift the object easily. Like effort is very less. So how the effort will become less, you can find it through the problems we are going to solve soon. So this is how pulleys work. Okay, pulley is for lifting heavy objects, and like in our place and all, we used to use pulley to draw water from well. So there is this well here, there will be pulley here. So one bucket will be here, and one person will be drawing water like this. So this is how this will be one platform here. So this is how we used to work for getting water. Okay, so this is how pulleys work. So it is easier to draw water from well using a pulley than putting this bucket directly into well. So pulley. There is a special mention here about friction. So first of all, we will see what is friction. Okay, so friction is a contact force. So if something comes in contact, so if two objects or two surfaces comes in contact with each other, and if those surfaces has a relative motion, so I hope you have learned relative motion before. So relative motion is what? When two objects are moving, like one object is moving with v1 velocity and the other object is moving with v2 velocity, an observer here will perceive that this object A, so object B has an observer on that object. Okay, imagine these are two cars. A is one car, B is another car. So one passenger in A is there and one passenger in B is there. So a passenger in car B, which is traveling with the velocity v2, will perceive, will feel like, will think like he will be seeing that, and a car with v1 is approaching him with a, like for him the velocity will be like v1 plus v2. Why? Because he is also approaching to A and A is also approaching to B. So he will be for an observer on B is not moving. So for him, the car is always around him. For him, the car seems like it is not moving. So that is it. So for this B observer, V equal to 0, and A moves with a velocity of v1 plus v2. Okay, so that is how he sees the object, sees the car A. For example, if you see, if two trains are there, okay, on two tracks, parallel tracks. So this is train A, and this is train B. See, both of them are traveling parallel to each other, okay, in a same track. This with velocity v1 and v2. For observer on B train, if v1 is greater than v2, he will see that this train is overtaking the other train. Overtaking in the sense like it is moving forward. I mean, you cannot cross the tracks for sure. So he will see that this B, the observer on B train will see that this train is, for him, this train is at rest, and this A train is moving with the velocity of v1 minus v2. So he was, if this train is traveling at 40 kilometer per hour, and this train is traveling at 60 kilometer per hour, for him, for an observer on B, he will think that this train is traveling at 20 kilometer per hour along his direction, and soon the train will disappear from his sight. Okay, but for an observer, like if both the trains are traveling in opposite directions, what will happen? If both the trains are traveling in opposite direction, what will happen? This is one train, okay, and this is another train, okay, this is another train. So this is moving with a velocity of 50 kilometer per hour, and this is moving with a velocity of 70 kilometer per hour. So for an observer in train B, he will think what? This train A is moving with a velocity of 70 plus 50 kilometer per hour, 120 kilometer per hour. That's why when you sit on a train and if you see another train which is going to the opposite direction, it will move really fast. You can barely see the passengers in that train. If it is like traveling at an 50 kilometer per hour speed also, you will not be able to see the passengers properly. But if two trains are going parallel, which is like very rare, okay, you cannot see such a sight. Because there will be a crossing in front, some track change will be there. So usually that is not the case. But still, if you ever happen to see two trains that are going parallel to each other along the same direction, you will be very well able to see the other passenger easily, because you will perceive a lesser velocity than the actual velocity of the other train. Okay, so this is called as relative motion. So it's a very very helpful concept in solving many of the problems and to understand many of the phenomena in our day-to-day life. So this relative velocity, if two surfaces are in contact, for example, there is a block here, there is a floor here. So this is one surface and this is another surface, right? So these two surfaces will come in contact, right? Will come in contact. So this distance is very small. This delta d is almost like zero. It is touching each other. So these two contacts come in. I mean, when these two surfaces come in contact with each other, what will happen is, if it tries to move forward, what will this surface do? It will try to stop that object from moving. So what will it do? It will provide a frictional force to oppose this motion. Okay. So what if this object moves to this direction? So this floor will provide a frictional force to oppose this motion. So friction is doing what? It is trying to oppose the relative motion between two bodies which are under consideration, like what we are observing right now. Okay, so it is a contact force. Only when two surfaces come in contact with each other, you will see friction acting on them. Okay, so why I was telling about friction is, this pulley is something which is like which will roll, which has a spherical or a cylindrical surface. You know that a log of wood will always roll in an inclined plane, right? It is very easy to roll. A tire, so all these kind of things will roll, right? It will all roll. So likewise, this pulley will also easily roll. But how? You are not rotating this thing. You are not touching the pulley. Only thing which is touching is the spring, right? So when a string is being pushed or pulled over the pulley, how it is rolling? It is because of frictional force acting between the pulley and the rope. So what will happen is, this is a pulley, this is a rope. We are assuming like it is over the pulley only. But to visualize this thing, what I will do is I will draw this rope over the pulley. Okay, so this is the pulley, this is a pulley, and this is a rope. And what will happen is, suppose M2 is greater than M1. Okay, it is given here. M2 is greater than M1. What will happen? This rope will move downwards. This will go upwards, right? So the motion here is like this. So what will happen? The pulley will try to provide a frictional force on this rope, which is like opposing this direction. So there will be an equal and opposite force. What will happen? On this pulley, this frictional force is like this. So that is why this pulley will also rotate along this direction. And this pulley will also rotate along this direction. Why? So first, we saw that this M2 is greater than M1. So that because of that, this M2 will move downwards and M1 will go up. That means the rope is going like this. Since the rope is going like this, if you see the surface, it will be like this is the ropes, this is the pulley surface. Okay, this is the pulley surface and this is the rope surface. So rope is moving like this. So pulley will provide a frictional force on the rope, which is like tangential. If this is the contact point, this tangentially the pulley will provide a frictional force. And since this is a action reaction pair, at this point on pulley also a frictional force will be provided like this. So that's why it will rotate like this. Okay, then I say rotation will happen like this. So this is a pulley block problem. Okay, so this is a pulley, like how pulley functions. So now we will be assuming something like ideal pulley. So ideal pulley means what? We won't consider the mass of the pulley. We won't consider the friction of the pulley. So we won't consider both the friction and friction being provided and the mass of the pulley. So now we are interested in finding the tension on string. So what we will do? We will simply assume that there is no frictional force here. So that external force we don't need to consider on the rope. So that is called ideal pulley. Okay, massless and frictionless. So this mass we are not considering. Okay, this we are not considering. And the frictional forces. Now, we will solve one problem. Okay, now we need to find the acceleration of the system. Okay, how to find the acceleration of the system? Suppose, so what do you think about the tension on the string? Will it be the same or different? So if we take this has T1 and this has T2, what will happen at this point? This point it will have T1 and this has T2. So if this point is not having an equal and opposite force, what will happen? It has to move to this direction, right? But in actual case, it stays in the same point. That means T1 is equal to T2. So along the same string, tension is always constant. So if it is going along the pulley also, this will be same. Now we need to find the acceleration of this system and the tension force on the string. So tension will act like this, right? Okay, how the tension will act? So this is T here, and okay, wait. This is also T here. So this is M2G, and here we have M1G. Okay. Now this object will go upward. This object will go downwards because M2 is greater than M1. Okay. So we need to find the net the tension here, tension force here. So we will draw the free body diagram of M1. So M1, what will happen? M1G is acting downwards. A acceleration is there, which is going upwards. Then we have a tension force T here. So T minus M1G equal to M1 times A. So T equal to M1 times A plus G. So that is the tension force here. Okay. Now for block M2, what will happen? M2. Here M2G we will be assuming. Here T is there. And there is an acceleration which is going downwards. So M2G minus T equal to M2A. So T equal to M2 times A plus G. Right. Now we will try to, if I take this as equation 1 and equation 2, we will add both of them. So what will happen? 2T equal to M1 A plus G plus M2 A plus G. Okay. Now, okay. Or you, okay, for easiness, we will take this as T minus M1G equal to M1A. This is equation 1. And T minus M2G. So this we will take it as equation 2. Now, if you add equation 1 and equation 2, what will happen? T minus M1G plus M2G minus T equal to M1A plus M2A. Right. Now, T minus T will cancel. So, M2G minus M1G equal to M2 plus M1 times A. So, acceleration here is what? A equal to M2 minus M1 times G by M2 plus M1. Okay. So this is how you find the acceleration on this string. Like you will get two equations from two free body diagrams, and then you will add them both to get rid of the T term, because for the entire system this is kind of like a what to say, it is kind of like an internal force. When you're adding them, the both of this thing, it will tend to cancel out each other, and you will be getting the acceleration here. So that is how you find acceleration. Now to find tension, you take any one of the equation. So I'm taking equation 1. That will give you T minus M1G equal to M1 times A. So T minus M1G equal to M1 times M2 minus M1G by M2 plus M1. Now T equal to M1 M2G minus M1 square G minus M1 G times M2 plus M1 by M2 plus M1. Now simplifying, you will get M1 M2G minus M1 square G minus M1 M2G minus M1 square G. Right. Oh, sorry. This is plus, right? It is going this side. So plus and plus. So this M1 square G will cancel out. So you will get 2M1 M2G by M2 plus M1. Right. Should I do something wrong? Let's see. M1. Okay. From here, if I do M1, sorry, T equal to M1 times A plus G. So that is equal to M1 times M2G minus M1G by M2 plus M1 plus G. Okay. Now that will be equal to M1 times M1 times m2g minus m1g plus m2g plus m1g by m2 plus m1, that is equal to this m1g and m1g cancels. That means you will get, so m1 times 2 m2g by m2 plus m1. Yeah, so both the ways it's correct. Okay, so tension equal to 2 m1 m2 g by m2 plus m1. So that is how you find the tension force that is acting on a pulley block system. And to find acceleration also, I hope you understood the method. So we will see further problems in the coming session, and then we will discuss more about pulley block problems. So that's all for today's session. Thank you.